At what point or points is the tangent line for f of x equals x times 4x plus 20 to the 2/3 A, horizontal, B, vertical? A horizontal line has a slope of 0. A vertical line has a slope of 0 in the denominator. The slope of the tangent line is the derivative. So we're going to find the derivative of this function f of x. Now f of x here is the product of x times 4x plus 20 to the 2/3 power. So we'll make use of the product rule for the derivative. The derivative f prime of x will be the derivative of the first, a 1, times the second left alone, 4x plus 20 to the 2/3 power, plus the first left alone times the derivative of the second. Now overall that'll be a power rule. We'll bring the power down. We'll leave the inside alone. We'll subtract 1 from the power. I will call it 3/3. And then multiply by the derivative of the inside to complete the chain rule. The first term is 1 times, we don't need to write that, 4x plus 20 to the 2/3. The second term, I'm going to bring this 4 out with this 2/3. 4 times 2/3 is 8/3 x, and then we have 4x plus 20 to the 2 minus 3 negative 1/3 power. Since I have a negative exponent, I'm going to rewrite that in the denominator. So my f prime of x equals to 4x plus 20 to the 2/3. Leave that alone for now. But the second term, this is going to move to the denominator, which means it'll move down with the 3. And left over are the other two parts of it, an 8 and an x. Those will stay in the numerator. 8x over 3 times 4x plus 20 to what will now be the positive 1/3 power. If we have a fraction in one or more terms and we're trying to find where the tangent line is horizontal or vertical, we need to express the derivative as a single fraction. We have to combine all the terms together over a common denominator. Now the first term does not have a denominator. The second term has a denominator of all of this. So we're going to need to multiply that first term by that expression over itself to produce the common denominator. So multiply this times 3 times 4x plus 20 to the 1/3 over 3 times 4x plus 20 to the 1/3 in such a way to produce the common denominator, so I can add together with this second term, 8x, over that same denominator. So f prime of x will now equal, for the first term, the numerator, we have a 3. I will write that down. We have a 4x plus 20 to the 2/3, and we have a 4x plus 20 to the 1/3. We can multiply those by adding the exponents. 2/3 plus 1/3 is a power of 1, so 3 times 4x plus 20. And then the second fraction, we have a numerator of 8x, so this will be plus 8x, because it is now over that common denominator of 3 times 4x plus 20 to the 1/3. The next step, I'm going to distribute the 3 in the numerator, so 3 times 4x is a 12x, 3 times a 20 is a 60, and we have this added to 8x. All of this divided by 3 times, and then 4x plus 20 to the 1/3 can be rewritten as cubed root of 4x plus 20. Combining like terms in the numerator, 12x and 8x can be put together to be 20x then plus the 60 all over 3 times the cubed root of 4x plus 20. A horizontal tangent line occurs when the numerator of the fraction equals to 0. So for our horizontal tangent line, we want a slope of 0. We want the numerator only to equal 0. So we'll take the numerator, set it equal to 0. A vertical tangent line occurs when you have a slope that approaches to infinity by the denominator going to 0. So we're going to want to take the denominator and set it equal to 0 from the derivative. That'll be the entire denominator. Set that equal to 0. So let's work with the horizontal tangent line first over here for part A. I'm going to subtract the 60 over, so that'll be a negative 60, and then we'll divide by the 20, so negative 60 over 20, and 20 divides into negative 60 negative 3 times, so we have an x-coordinate of negative 3. We're going to want to get a corresponding y-coordinate by plugging into the original function. Make sure to use the original function, not the derivative, so we're going to want to have an f of negative 3, which will be negative 3 times 4 times negative 3 plus 20, and then that entire thing to the 2/3 power. So negative 3 times 4 times negative 3 is a negative 12 plus 20 raised to the 2/3 power. So the y-coordinate, f of negative 3, will be negative 3 times negative 12 plus 20 is an 8 to the 2/3 power. So we have negative 3 times 2/3 power means cubed root, so we'll take the cubed root of 8, which is a 2, and then you square that result. So I will have a negative 3 times a 2 squared, which is a 4, and I'm ending up with negative 12. We have an x-coordinate of negative 3 and a y-coordinate of negative 12, so negative 3 comma negative 12. There's the answer for the horizontal tangent line. Now for the vertical tangent line, we want the denominator equal to 0 for part B here. I'm going to divide both sides by 3. And, well, 0 divided by 3 will remain a 0. And now we're going to raise both sides to the 3 power because of the cubed root. Cubed root cubed cancel each other out. And we have 4x plus 20 equals to 0. Which means that 4x equals to negative 20. We subtract 20 from both sides. And x will be a negative 20 divided by 4, which will give us negative 5. There's the x-coordinate. I want the point, so I'm going to want the corresponding y-coordinate by plugging that x-coordinate in the original function. So our y-coordinate will be f of negative 5. And that will be negative 5 times 4 times negative 5 plus 20, the entire thing to the 2/3 power. So we have negative 5 times 4 times negative 5 is a negative 20 plus a 20 to the 2/3 power. And so y, which is f of negative 5, will be a negative 5 times negative 20 plus 20 is a 0 to the 2/3 power. 0 raised to 2/3 means the cubed root of 0, which is 0, and then square that, which is still 0, so it's negative 5 times 0, or just 0. We have an x-coordinate of negative 5 and a y-coordinate of 0. So we have a horizontal tangent line for part A at negative 3, negative 12, and a vertical tangent line at part B for a negative 5 and 0.